Hello and welcome to day 22 of my Advent of Code series for 2020. If you've missed any of the previous days, then go ahead and check out the playlist right up here to get caught up, and be sure to get subscribed to me so you don't miss any of the future days. So today we're tackling day 22, Crab Combat. So we are bored on our raft. Luckily we brought some cards, so we teach a crab how to play combat, and we just want to go ahead and simulate that game. So we get our starting decks as our input here, and what we need to go ahead and do is just figure out who wins and then return their score. So combat is essentially war, but without the possibility of ties resulting in wars. So what we do here is both players take their top card, highest card wins, and then that player gets both of those cards, putting their card on the bottom of their deck, and then the other player's card on the bottom of their deck. So we go ahead and run through that. And then we just need to return the score of the player who wins, where the score is going to be the sum of 1 times the bottom card of the deck plus 2 times the second bottom card, and so on through their entire deck. So that is going to be it for the instructions for part 1. We can go ahead and jump into my code, but I recommend you go ahead and give this a try first. And here we are. So the first thing that I do is our read decks function here is going to give us a list containing our 2 decks. So how this is going to work is we split it on our 2 new lines, and then I go ahead and split those down further into the lines, discard the first line that just has the header, and then convert each subsequent line into an integer. So that's going to give us a list containing lists that represent our 2 decks. So then we just have this utility function here for get score. So what this is doing is it's just doing that accumulation by reversing the deck, and then it is going ahead and adding to our answer value times the index that we're at in the reverse deck plus 1, because we're supposed to start at 1 for those multiplications, not 0. So then we can jump into our part 1 function. So this part 1 function here could theoretically also work for more players. I had a feeling it was going to do something like it did in some of the previous days, where it just adds more input. I thought maybe it'll add another crab or something like that, and we'd have to do it like that, but I guess not. That didn't end up being it, so this didn't end up being necessary to generalize it like this. What we do is we check that our decks all have a length greater than 0, so that means a player hasn't lost yet. And when that's true, we go ahead and get our current cards, which is just going to be a list of the top elements of all of our decks. So we just pop the 0th element right there. The winner is going to be the index of the maximum value of current. And then what we're going to do from there is we're going to add to that deck, we're going to extend it with the sorted version of cur in reverse. So what that's going to do is that is going to give us the maximum value and then the lower value, just so that we get the things added onto our decks in the correct order. And then we go ahead and run our get score function on the maximum value of decks, which is going to be the deck with the longest length here, which is our winner, and we return that, and that is it for part 1. So then we can jump into part 2, where we want to challenge them to recursive combat instead. So here how this works is recursive combat starts by splitting them into 2 decks, and then the game is a bunch of rounds with a few changes. So before each player picks the top card from the deck, they check if if this round has already happened essentially in this game. So that means that both players have the same exact decks in the same exact order. And if so, then player 1 just wins that game. Otherwise, they're in a new configuration, so they both draw their top card. If they both have at least as many cards remaining in their deck after as the value on the card that they drew, then they play a new game of recursive combat, where if you look at the rules down there, how it works is they just take the top number of cards equal to the value that they drew into that subgame, and then the winner of that subgame ends up winning the round. But otherwise, then they don't have enough cards to recurse, so they just play a round of combat like the normal game of combat that we had in part 1 to determine the winner of that round. So then how that works in the end is we just need to find who wins the first game, the overall game that they play, and that is going to determine the winner, and we just need to find their score. So I recommend you go ahead and give this a try, and then we will jump into my solution right now. So the way that I did this is I just decided to represent each game as an object, because I found it to be much easier that way, just instead of having to pass a bunch of function parameters every single time. So in our initialization function, we take in both of the decks, and we go ahead and assign those decks, and then also create a history set, which is just going to be what we're checking against every single time to make sure this round hasn't already happened in this game. So then while both players still have cards, That's one stopping condition there, because if one of the players doesn't have cards, then we go ahead and return whoever won that round. But if they both do still have cards, then first we go ahead and check if this round has already happened. So the way that I represented things in our history is I convert both decks to tuples, and then I put them into one tuple. So if that tuple is already in our history, then we just return the player 1-1. Otherwise, we go ahead and add it to our history, and we continue on with the next thing here. So what we're going to do is we're going to pop both of the top cards from each of the decks. We're going to check if both players have enough cards to keep going, and if they do, then what we're going to do is we're going to if they don't have enough cards to play a sub-game, then what we do is we just play a normal round of combat right here. But otherwise, what we go ahead and do is we create a sub-game by initializing another game object with just the top number of cards equal to whatever the value they drew is, and we play that game out. So then if player 1 wins that game, then we go ahead and add the cards to player 1's deck, and if player 2 wins, then we go ahead and add them to player 2's deck. And then what we do is once we finish, if we end up finishing our while loop, so if a player runs out of cards instead of us ending by the history condition, then we go ahead and return a 1 if player 1 still has cards, and otherwise we return a 2 because it means player 2 won. So then in our actual part 2, what we do is we just initialize a game function, we play out our game and store whoever won, and then we go ahead and find our winner's actual deck. And then we go ahead and just get the score of that winner, and that is it. So I hope you enjoyed today's video. Again, a little bit of a easier one. So today and yesterday were both a welcome break from the much tougher problems that we've had in previous days. But I hope you enjoyed. If you did, be sure to get subscribed, leave a like on this video, and turn on post notifications for my channel so that you don't miss any of my future uploads. And please let me know in the comments what you want me to do. If you want me to continue a series doing something similar to this after Advent of Code is over, I could go through algorithmic problems on LeetCode or something like that. LeetCode is doing essentially daily problems now, I think. So I could go through that if you guys want, or I could do something else. Just go ahead and let me know what you think, and I will see you in the next one. Goodbye.